Again, engineers, let's have another example. This example we talked about briefly. The difference in this example from what you've been asked to do so far is the translation from words into the algorithms. I'm hoping that's not a huge leap, but I don't want to take it for granted that it is something easy to have done. And so I want to kind of talk a little bit about the areas in the formula as well. So they talk about initialization, calculation, results. That's a made up thing. That's a useful made up thing, but it's not a formal coding structure. It's just a helpful coding structure to help you organize your thinking. So the problem, again, we're going to have an acceleration factor. G is 9.8 meters per second or 32.2 feet per second. There's some constants inside of there. Then there's a formula for calculating the amount of time before a object would hit the ground if you drop it from height, whether you're standing on a tower or dropping in a pit. Formula is the same. Doesn't matter what the object is. Um, at least if you ignore for wind friction and the air friction and such. So the velocity it hits the ground is the second formula there, the square root of 2 times gravity times the height. And the energy is 1/2 times the mass times the velocity squared. So the important thing to pull out of this discussion is what are constant values versus what are things that you might calculate differently depending on the time of day, the problem you're solving, that would be reusable. There'd be inputs. If you're building a computer program, what would you have somebody type into the computer or click on their phone in order to change what they're trying to compute? So in this, looking at this, gravity is constant. You know, as long as you're on the planet Earth, the pull of gravity is always the same. Again, good enough for rounding error. If you get really, really far away, maybe it's fractionally smaller. The height already is a variable defined here because we haven't given a height yet. The 9.8 seems to relate to this gravity, so we got to be careful about that. We don't want to have magic numbers floating around. If this is indeed the same thing as gravity, we're going to make sure we reuse it as it is gravity, like you say G here. So that's a little bit of a trick that I intentionally threw in here to kind of talk about that. So G is here, and then the last variable seems to be mass, because velocity is something we can calculate. It's a derived based off of the formula. So let me get away from this slide real quick, and then we're going to start a new script. So in Matlab, I'm hitting the new script button, and it's blank and untitled, and that's good enough to start from now. So when you start homework, you're going to have a template that's going to have a header up front. It's going to have a bunch of other stuff. That's super important to do for the homework. I'm not doing it now just to save space, so I don't have to scroll as much in front of you. So you can call it G if you want to. I like words because I type fast and it doesn't matter, but gravity is equal to 9.8. Best practice, go ahead and put a comment on that, meters per second. Oops, I put a dollar sign. I wanted to put a percentage, meters per second. So I know what the units of that is. You could even name the value gravity in meters per second. It's not a trivial thing. They once lost a Mars probe that was supposed to land on the surface of Mars, and it hit 3 times harder than it was supposed to be because the American engineers did their code in feet per second, and the European engineers did it in meters per second, and they forgot to convert it when they go back and forth. So it hit way harder than it was supposed to, and crashed and burned, and hundreds of millions of dollars went down the tube, or at least tens of millions. So it is a thing, and units are important. All right, so beyond the gravity, we also have a height, and we don't have a height yet. I'm going to put it at 10. And again, I want to be super careful about this. I'm talking about meters. And then there's going to be a mass involved at some point. By the way, you don't have to do this, but I like to line my variables up. I think they're easier to read that way. And so the mass is, I don't know, let's see, 2.2 kilometers. So let's say 91. I'm around 200 pounds. We'll say I think 91 should be around 200 pounds. And that's kilos. All right, so those are our variables. This one is very much constant. These two theoretically are inputs, but we're not actually getting inputs into MATLAB at this point. maybe deal with that down the road. But conceptually, I hope you understand the difference. Something that will never ever change, something that every time you want to compute this, you might have a different height or a different body mass that's falling. So the next thing we need to do is figure out the time. So I can call it time, but what time am I talking about? It's time to impact. And I'm going to show my Java roots inside of here, my C roots, and doing what's called camel case. I'm putting the higher name, the higher letter, the uppercase letter between each of my words. If you're more comfortable, I don't even know if the coding standard speaks to this, but you can also name your variables like this. This is the Ada way, programming language I first started in my professional career, and I like this. I actually like this better. But as in all things, if you see something enough, you get to read it. So the two of them look exactly the same to me. I can read them both equally the same way. So I'm going to stick with this because that's what my habit is. So time to impact, and so that calculation. Let me pop it up again briefly so you can see what I'm doing. So it's 2 times the height divided by gravity and the square root of that number. So the square root of 2 times height times gravity. So that's what we have to do. So I can do SQRT of 2 times the height divided by gravity. I think I'll double check myself. And square root of 2 times the height divided by gravity. That looks good. Oops, I'm going to take away my semicolon here. And, I have to save it. So I actually saved it once. I already called this free falling. So this is example free fall. We'll see how well I do now versus the one I did before. So the time to impact is 1.42 meters is what it's saying. For me to check that, I should do the calculation by hand. I should double check it that way. I'm not saying you shouldn't do that. I'm not going to do it here because this is a short video and I'm going to keep a short video. And 2, I'm probably a better coder than I am at math at this point in my life. So I'm going to trust myself at this point for the moment. If you find me wrong, hey, excellent, bonus. I'm glad to be proven wrong when I actually am wrong. All right, so that's the time to impact. So velocity at impact. I could just call it velocity. That would be fine, but I am calculating a very specific value. So my velocity at impact, then is the formula for that is the square root of 2 times the gravity times the height. All right, and I'm going to leave that without a semicolon again so I can test it out again. And oh my gosh, unrecognized variable g. Okay, so what I did was I was looking over at my other screen. On my other screen says, I'll show it to you again. Two times g times height. That's the formula that went there. So I made the choice, maybe badly in this case, that my source material called it g. I called it gravity. So when I see unrecognized function or variable, I have to recognize like, oh, well, this isn't defined yet. But in my mind it was, because I defined it right here. But I spelled it differently. Yes, it's obviously different here, but even if I had called it gravity, it wouldn't work. So I run this again. Gravity with a capital G, unrecognized variable gravity, because Matlab is case sensitive. So I can do lowercase g gravity, and that comes back. It's 14 meters per second when it hits. So if I fall 10 meters, then I'm doing slightly faster at that point. All right. So then the last equation inside of here is the energy at impact. And that's going to be equal to 1/2 times the mass of the object times the velocity at the impact, the one I just created, the variable here, velocity, squared. And that is the caret character. That's what this little guy is called, Shift 6, at least on a standard keyboard, second power. And let's see what that energy is at impact. So 9,818, I think that's joules. I'm guessing there. As I said, I'm a software engineer. I don't calculate these things very often. So there's my sample. just to check myself here, and I'm cheating checking myself. It's not even the best check because I should be calculating these by hand from other sources. But given the algorithms that I had, which may or may not be right, and I actually checked myself against the website, so that's why I trust this other one. But free falling, I chose 22 and 91.6. The code I think looks the same. Let's see. Yeah, that looks mostly the same. Oh yeah, I did the to the 1/2 power here instead of square root. But let me check. Let me use the same example I got here. So 22 for the height. I don't know why I picked 22 meters for the height. Um, Maybe just a nice number. And 91.6 is probably closer to that 200-pound mark. Um, and so let me run this one, and it said 2.1 seconds fall time, 20.7 velocity, meters per second velocity. And so if I run this one, 2.1 second fall time, 20 velocity, looks like it's about the same. So there's a quick example of taking a little bit simpler algorithms than what the problem has and reading through them and converting those into code. I didn't run into a ton of errors along the way. I didn't make any huge mistakes, but hopefully the little mistakes I did make is something that helps you kind of work through some of your mistakes. My suggestion, having seen this, is probably go back, if you didn't build it along the way and pause, do that. Build it. If you can build it without watching the video, even better. But feel free to walk through and look at each line I typed and match up line to line. It's a good strategy to help you develop the implicit memory that's going to help you code better.